Good day. I am going to show you how to prepare the tunnel in Revit. So there are different ways, preparing tunnel. Maybe into Civil 3D by subassembly composers, and but this is the best workaround which I have found. You can see here there are two stations, and in between I have created a twin tunnels, and this has been created within Revit. So yeah, I will show you how to create this tunnel into Revit. So a little bit different description or brief introduction of myself. I am civil engineer and AutoCAD expert elite member, having experience of 11 years into BIM with design and construction phase, and have worked with different type of structures, which includes hospital, residential, commercial, water related structure, which include wastewater treatment plant, dam, hydropower, etc., and elevated and underground metro. So the tunnel which I am going to show you is for the project underground metro, and currently working with Tata projects as a BIM manager. So we will go into the sequence. So the sequence includes, first of all we have to create coordinates and export them into the Excel. And I have created a Dynamo script wherein we can import the alignment into the Revit. So we have to use the Dynamo to move the coordinates from the Excel to the Revit Adaptive family, and then we will be creating a tunnel in Revit Adaptive family, and then that family we will be loading into the Revit project file. So here it starts the process. So basically, from tunnel alignment we are going to get the northing and easting, that is y and x coordinates, and from the profile we are going to get the z elevation. And into the profile you may get different levels like rail level, track level, and ground level. Or so that from that particular that particular center of track we will have to calculate the center of the tunnel, and that will behave as the elevation for that tunnel. So the procedure is actually, you can see I have written here, we need to create the points, AutoCAD points at a given chainage, or you can divide the alignment into the number of points, number of units to place the points into AutoCAD. Convert that AutoCAD points to Kogo points and export that points into text file. Open this text file into Excel and then save it into the Excel format. So now I'm going to show you the procedure for the same. So I'm opening Civil 3D here, wherein you can see the alignment. Here this is a underground station, again here there is an underground station, and in between there is a tunnel in between. Okay, so what I am going to do is I am going to break here and and this alignment I am going to copy into another file. I will always make sure that I am very much near to the 0, 0, 0 coordinates, because while exporting these points into adaptive component we get lots of issues there. Okay, so here this is a alignment, and we at this point of time I am not taking the chainage points into chainage, because that again includes the manual efforts. You can manually place the points into that sequence onto the chainage, but currently I am dividing this in equal parts. I am dividing into say 100 equal parts. Okay, the points will be placed onto this divided parts. So you can see the points are there. These are the AutoCAD points. So to convert them into the text format or maybe into the final Excel, we have to convert this into Kogo points. So I am going to show you how this is going to get converted into the so here there is a conversion of points, normal AutoCAD points to the Kogo points. Selecting it, hitting enter, but at this point of time you can see that it starts from here in between, and I don't want to start from here. I want it to start from this point. So what I can do is it starts, so we have to do something manually so that it first takes this points and then it takes this points. Otherwise what will happen that into Excel or into text you will have this points, the points are starting from here will be your initial points, and this will be a in between the other points will be coming, and which should not be happening. So what I am going to do is I am going to Control Z. I'm going to hit Control Z. Yeah, I am back. I will hit convert points. Okay, say this again starting from, I need to see where it is getting started. So it is starting here. Somewhere. So now it will start from here and there, and then again you can select that, and then it will start from there onwards. So this is how you will have to do, maybe 2 to 3 times to export that into the into text file. So currently I am showing you into this way. So my purpose is to show you how you can export this into the text file. So yeah, now we will be exporting this into the text format, and then we will make into the Excel. I will put a destination, say test points. Okay, I am writing test points. Okay, open, and I will say hit OK. Yes. Oh, the points have been exported. Now I will go into the Excel and will open that file. Yeah, into this you need to put this as a text file here, or maybe all files. So this is the text file which we exported from the Civil 3D. I am opening here. Yeah, and I will hit next here, and I have to divide this into the so that it gets into the separate column, and then hit next, and then finish, and then you will have it into the Excel format. So now you have X and Y coordinates from the profile, and Z coordinates will be shown as a 0. So this Z coordinate you will be getting, as I already discussed, you will be getting that from the profile, and from the profile you will be getting the track, center of track, and from the center of track you will have to calculate center of tunnel. One center of tunnel is that you can put here to do the same. You will have to do that manually to at the chainage, at that current chainage the elevation will be so and so and so. Okay, it's not responding. It's okay. Yeah, we were into Civil 3D, and yeah, we have exported, and yeah, what will be the next? We have done this. we have opened the Excel file, and then we will have to save that file. Yeah, we will have to save that file as a Excel. Currently something is going wrong with this, so but yeah, you will have to save it as, once you prepare this, so you will have to save this file. Something has gone wrong, yeah, so maybe so yeah, I am opening once again, and then we'll save it so that it gets, yeah. So this was a text file we created, and then hit next. I want to divide into the columns, yes, finish, and then I will have to save as this file into Excel. Yeah, so you will have to put here is Excel and then save it. Yep, so you can see that it has been saved here as a test Excel file. Okay, so what is after that? After that, we need to open Revit, and into Revit we need to use a Dynamo script. Oh, and then we have to open the Dynamo script. I have created a Dynamo script wherein from the points we will be creating an alignment into the Revit Adaptive family. I will show you how we can do that, and you need to browse the Excel file and need to change maybe the sheet name, and the alignment will be created. I will show you the same. Yeah, so I'm closing it, yeah, close it. So this is basically we will be doing into Revit family generic adaptive component, generic model adaptive. Okay, yeah, so here we are going to create a alignment with the help of Dynamo. Yeah, this is the file which I have created for creating alignment. See, I do not want to yeah, into the latest version. I don't want it to change that to latest version, but yes, I am using the same. So this is a script which will create alignment. So what you have to do is I can provide you the same Dynamo script, but it's very simple. You can create a first of all points, and then you can create a curve of that. That means it is alignment. You can delete this. So here I am going to browse the file which I have created. So this is what I had created. We had created actually this one, but I am going to use this one which I have already created it. So yeah, because this includes the Z elevation into it, and this doesn't include the Z, which we have to calculate it from the profile. Yeah, I am going to open this, and this is a file. Yeah, and the sheet name is points for tunnel. Okay, so I will use Control C to copy, and then I will copy and paste here the sheet name, and as soon as I put that, and it will run, and then the alignment will be there into Revit. Hopefully, yes, it is there. So I am here with the alignment into Revit family adaptive generic model adaptive. I will switch off here. This is one procedure. So what is after that? We have created the alignment into Revit. Okay, and now what? Once alignment is created, we need to uncheck the visibility of reference points, because that will create a confusion for us. And then we have to divide that alignment into the into the number of parts, and the maximum number of parts is 200, which is limited into the Revit. And we will be creating a tunnel profile in a separate file, loading into the alignment file, place it, and then repeat that onto the alignment, and we will create a solid from it, and then we will create a very much similar profile for creating a void inside the solid. I'm going to show you the procedure for the same. Yeah, we have the alignment here. I will uncheck the visibility of reference points, so that now I will be dividing this. Currently it has been divided into 6 parts. I will divide maybe in say 25 points, and maximum you can divide up to 200. So I have divided it into parts. Now I will create a profile. I am going to use the same adaptive family to create a profile. Into reference label, I will create a circle here, say of radius 275 mm. It is actually 2.75 meter. Okay, yeah. So it is 2750 mm. So once I have created this, I will load this into this is a family 3. I will load this into here, and then I will place here. Once after placing, I will select this, escape, and then select, and then I will use the repeat command, and this will repeat the same onto the divisions which I have done. I will select them, remove the repeater, and create solids form. So this is a solid form created for my tunnel. Inside I have to create another profile to create a void. I will use another family to create profile. New family, generic model adaptive. Okay, and again I am going to go into reference level. So it was 2.75 meters, so I will give 65 meter. Hopefully the difference between this is, I just want to check it, 2.75 meter. Yeah, so this difference is okay, and I will load this is as a family 4. Okay, load into the family 2. Okay, and I will place here. I will select again. I will use the command repeat. It has been done, and then you can select, remove the repeater, and again create, this time as a void. You can see the tunnel has been created. So nice. Yeah, right. So this is how we can create a tunnel. Similarly, we can create another tunnel beside this, or you can create a separate family for that, or else you can create into the same family, and then you can bring this into the project file. I'm opening the project file, new project file. Now I will load that family 2 into the project file. Yes, into project. I can place, yeah, okay. So I am into Revit now. Can see we will have to place we will have to go into the elevation, adjust it as per elevation. I will show you the example that I have done, and this is how I have done for one of the project. This is the twin tunnels I have created in between the stations. You can see there is underground stations here, and then these are the twin tunnels. Can enabling the sections here, and this is how it is. See, this is tunnel we have created. So similar way you can create the tunnels. Hopefully this makes you understand how to create a tunnel